Yeah, this, no, this way. This there. Yeah. Make sure it's lined up against this. Because it's been a bit, some of you slept a lot, some of you worked a lot, right? So you can tend to forget. So this unit, chapter 5, is split up into triangles, which we started on Thursday, quadrilaterals, which is four-sided. You can call them quads if you want, and then polynomials. And really, we will learn that polynomials encompasses everything, every shape, every geometric shape we're going to be talking about. And then we reviewed Pythagorean Theorem real quick. We noticed that we had two different cases. When you're missing the longest side, the hypotenuse, you just add the squares and square root it. If you know your leg, you need to take the hypotenuse, subtract the other leg. Obviously, always squaring, and then square root it, and then you get your answer. That'll come in really handy when we, especially when we work with triangles. So we keep going. 179. If you quickly go with me to 179, we basically started naming, classifying as naming, right? Triangles by side length and angles. Okay, so I don't know. I will add that here for you here. So if you want to classify by angle measure, you have three options, right? It's acute, right, or obtuse. Okay, those are your three options for classifying it based on the angle measures. And then side length. You have equilateral, sorry. You have the isosceles. And you have the one we don't really hear much about, but most of our triangles are scalene, right? Most triangles we work with are scalene. Maybe what I will also say is that these two folks here are symmetric. Symmetric means that symmetrical or symmetric is when you cut it in half, you get two exact same halves. The base is actually split in half. But a scalene, you cannot make that assumption. How about we do this? This one is asymmetric. That's all. This is all really review from Thursday, but it's just quickly running through it again. So we know what we do. So basically, this is the first name, and this is the last name. Every triangle has a first and a last name. However, if you mix it up ever, if you name this first and then that, I don't care, as long as you have both names there attached, okay? And so we went through example 3 here. We ended up naming the triangles that were there. We used some Pythagorean theorem and so forth. So that's all just review. So I'm going to get you to go to the next page. And there we did a bunch of examples on classifying. And I think what I will do is I'll give you a couple more today to practice. Okay, let me just look up. I have some examples here that I made up where you can see if you remember. I think let me just look here. Yeah, if you go to 181, page 181, I gave you a bunch of examples there. And I'm hoping you only used about half of the space, right, on page 181. So I'm going to give you some more just to do a quick review. That's what the EC is all about, by the way. 181. So I'm going to split this up here and just say classify. Okay, basically what you want is name and last name. Right? If you can remember that, it's like, oh yeah, I know exactly what classifying is. It's just giving it a name and a last name, right? So let's see here. So this one is asymmetrical. And I will go ABC like this. 50, 40, that's it. 2 angles there. Let me zoom in a little bit. I can probably get a bit more in there. So this is a 50-degree angle and a 40-degree angle there. Let's try another example right next to it. I'll make a mark there and a mark there. And say that this is 40 in this corner here. And we're going to go D, E, F like that. I just want you to get used to the letters. And then the third example. And here we're going to go H, I, G. And we know that these two have a mark here. And we know that this one has 45. And then we're going to do 3 below it. So leave some room so you can name it. Right? So I'm going to go A, B, C, D. We're going to go like this. And this is F, U, N, triangle fun. So that's 120 degrees and then 30 degrees. Example E. I'm going to do 2.5 inches. 2.5 inches. We're going to have this angle up here being 60. And last, this one actually was ABC here. ABC. DEF. 2.2 inches. 2.3 inches. 3.8 inches. Okay. If you have, grab a red pen or something like a different color or blue pen, it doesn't matter. And so while you're going through this, you should fill in some information in there that will help you decide what kind of a triangle it is. It's kind of like fill it with as much info as that you can possibly get it based on what you're given, and then give it a name and a last name. Do the naming with a pencil though, but if you're going to add angles or anything like that, I would say use a different color so you know that's what you did after you were given some information. Okay, so go ahead and give it a first and a last name, see how you. So again, I say that the angles will give you information about the sides, and if you forgot that, I'm going to go over it in a bit. Right? So I'll guide you through it a little bit, and I'll think out loud so you know how I would do something like this. So when you have two angles, it's very easy to find the third one, right? In fact, 50 and 40 is 90. So you know this has to be 90, right? There's no other way. So if you go by angle measure, this would be a right. For sure, because of the 90, as soon as there's a 90, it is a right triangle. Don't even look at the other ones, right? It could be an isosceles, so right, and then because all three angles are different, what do we know about the side lengths? They're also going to be different. Guaranteed. 3 different angles, 3 different sides. You don't even have to know what the side lengths are. So we're going to go scalene, right? And I will make a note somewhere else later. All angles different means all sides are the same. So we're done there. Here, I know that this side has a 40 across from it. Therefore, this side, which is equal, will also have a 40 across from it. So we know already that this is an isosceles. That's not a question, but you want to check, is this maybe, could this be a right triangle, right? Something like that. So if this is 40 and this is 40, that's already 80. So this has to be 100. So you'll be able to do quite a few of them just like that, just mental math there. So we know that this one is, in terms of angle, this is obtuse. And obtuse, and because these two sides are the same, we know it's isosceles. Okay? This 100 will have the longest side across from it, but we know it's going to be different than the other two, so it's an isosceles. Next, we have that across from this side you have a 45. That means that across the other side that's equal will also be a 45. Okay, that's what I always do. And so 45 and 45 is 90. That means that this is actually a 90 here as well. Right? You can write down 90 if you want, or make that box. So we know that this is a right. And because we have two sides that are the same, isosceles. Bingo, right? Next, we know for sure this is obtuse. We don't even have to wonder about that. In terms of angle measure, it's obtuse. If this is 120 and 30, that's 150. So this must be 30, right? And what do you notice? Two angles that are the same, right? Watch this. If you know that these are the same, then the sides across them are also the same. Like, that's just the rule. It goes both ways. If the angles are the same, then the sides across those two will be the same as well. So we know this is an isosceles. Isosceles when it comes to side length, right? So by angle, by side length, done. Here we have no markings, but you're knowing that 2.5 and 2.5, they're the same, so you can actually do this. And across this side, you have a 60. That means across this side, you have a 60 as well. And then you're like, wait a minute. If this is 60 and this is 60, this has to be 60 as well. And that actually concludes that if all three angles are the same, then all three side lengths are also the same. See, I'm just putting as much information as I can on there, and then you just call this an equilateral. No, that's the one you don't need two names for. It's just equilateral. You can say acute equilateral, I won't mark it wrong, but this is the one you don't need two names for. Okay, and here, watch this. Watch my markings. All three sides are different. That means that all three sides are going to be different. They all, right? Like if you have 3 different markings, that means that they're all different. But this does look like an obtuse, doesn't it? So you go obtuse, scalene. And soon I will make you draw them. Like if I say, hey, draw me an obtuse scalene triangle, and I will ask you to do that, and you'll have to put the markings in or put numbers in, whatever you feel like you need to do to make that happen. Good? You know how to name them now, right? Let's keep going. We did 182 there. Page 182, I asked you to work on questions 4 to 6. On 182, 4. So yeah, so 4 to 6, which was, this one would have been the 6th question here. So let's go over that. I started going over this page, 182. We're going to go to 183 here and tackle that one. Here we go. An asymmetrical roof on a shed as seen below has sections 18 and 14. So you can see the diagram below, right? So I will go down to the diagram in a bit. It says, how wide is the building? And the roof has a rise of 6 feet. That's also important to note, right? So I'm just gonna highlight those things. 18 and 14, right? The rise is 6. And how wide is the building? So everything is already filled in the diagram here. So to find the width, you got to go from here all the way to here, right? That's the width of the building. And you can see already that they've split this into 2 triangles. So this is number 1 and this is number 2. Okay. How are you going to tackle this? Well, I will find side X or side, yeah, and this is going to be my side Y here. Okay, that's my approach. And I can use Pythagorean Theorem for both sides because they're both right triangles. So for number 1 here, X is one of my legs, right? So X is going to be found by going square root of the hypotenuse squared minus this 6 here is 6 for both sides, right? And I need to go grab my calculator. There you go. 18 squared. Make sure you know how to do this on your calculator, right? So this is 288. So square root of 288 is 16.9706. 16.9706. I'm going to use 4 decimals as I'm still working towards the width. So you round it to 4, and we are in feet. And then my second triangle, this one here, to find y, it's also one of my legs. You take the square root of the hypotenuse squared minus the other leg squared. So y is equal to 14 squared minus 36, right, essentially. That's 160. Take the square root of 160. 12.6491. And we are in feet. 4 decimals while you're working, 2 decimals final answer. So the width, or W, would be X plus Y. So I'm going to take 16.9706 and I will add, oh, you can't see that, can you? Plus 12.6491. Some of you might get the same answer even though you rounded to 2 decimals along the way. Well, you're lucky. right? Sometimes it affects, sometimes it doesn't. If it doesn't affect, I won't take marks off, but if it does, you will lose half a mark there. Right, so this is my zoom in a bit here. So this is the answer, 29.62. This answer is A, by the way. And now we're going to classify now the fun stuff. So there'll be some solving and some is classifying in this particular case. So let's put an A up here. This answer is A. And then we'll answer B over here. Watch what it says. We're going to classify triangle ABC first. Triangle ABC, if you look up here, A, B, C, it's this right triangle, right? We know that this is 6, this is 18, and this is, we just found that this is 16.97. So what do we know? Well, by angle, it's definitely a right, and by side length, it is a scalene. Done. All three sides are different, but you do have a right triangle. Now we're going to go triangle ACD. You're going to see this a lot, by the way, a triangle, and then they're going to use the letters to highlight a smaller one. So ACD, it's this one. And I know this is 14, this is 6. And Y, right, the bottom here, I just found that is 12.65. And again, this is a right scalene. All three sides are different, but you do have your right triangle here. Okay. Next is triangle ABD. So ABD, it's talking about the whole thing. And here is a little bit of a, this is tricky, okay? Trickier. Let me draw it out. Draw it out, please, as best as you can. Okay, like this. We know that this is 18, 14. This is 29.62. Maybe only I suspect, but I hope you suspect too, that there's a chance that this angle up here is an obtuse. Wouldn't you think so? There's a chance. So we're going to show and make sure that whether or not it is. So what? Remember SSS? What could you use for side, side, side? Sine law or cosine law? Cosine law, right? So we're going to find angle A. So cosine of A, and I know some of you did it differently. That's okay. There's many ways to get there. I need to find, I'm going to have this side across like this, and then it's 18 squared plus 14 squared, right? Minus, make sure it's minus the side across the angle you're trying to find. And then it's 2 times 18 times 14. And basically, this is what I'm going to check here. If the top is negative, I know it's going to be obtuse, correct? If you get a negative out of this, which is negative 357.3444, it's game over technically, but I'm going to finish this. So angle A is going to be cos inverse of negative 357 This is why I do trig before I do geometry. Negative 0.709 dot dot dot. Take the inverse. Hold on. Sorry, mine is set to shift cos of negative 0.709. I don't know what came after, sorry. But that's okay in this case. It's 135.15 degrees. So put an arrow going up to A. You just found that that is obtuse, so therefore this is an obtuse. Obtuse what? All three sides are different, so it's scalene. That's why trig is going to keep going and follow us wherever we go. Right. So I had to do the check because don't just go by the diagram on a question where there's a bunch of information given. You have to actually figure out what's that number. Okay? So because of this, I called it obtuse. I have to make that check, right? If it doesn't have enough information, then obviously you don't worry about it. You would just go by the diagram, in fact. Okay. Backside. So let's see what we have here. The perimeter is the distance all around, by the way, right? So if you add up, if you were an ant and you walked all around, is the distance around the shape. So if that's 90, then 30 and 30 is 60. This must be 30 centimeters, right? 3 times 30 is 90, right? So classify the triangle by side length and angle. Because all three sides are the same, this is an equilateral. You don't even need to know the angle measures. Equilateral. There you go. Done, right? Yeah, could they have asked you for each specific one? They could have. But in this case, it's just asking for triangle. This is triangle X, Y, Z. X, Y, Z or X, Z, Y. It doesn't really matter as long as you have those three letters there. We're done with the naming part. Now it says calculate the area of this triangle. We need height, right? So what we're going to do here is we're going to cut this, and because this is a symmetrical shape, if it's symmetrical, when you cut it, you're actually going to split that in half, right? You're going to divide that by 2, so this turns into 15, and this is 30. And this is, I don't know, you can call it H, you can call it X, whatever you want to do there. We know this is a 90 there. That's going to give us our height. So this is a leg, right? This is the hypotenuse. Leg and leg. So all we would have to do is take the square root of hypotenuse squared minus the other leg squared. So it's 900 minus, that's 675. Take the square root of that, that's 259808. Because of we're still working towards our area, this is important, but this isn't my final answer yet. Definitely would score you marks there. The area is base times height divided by 2. So what's the base of this triangle? don't use 15 because then you're just finding half of the triangle that they're actually talking about. We're going to use the base of 30 centimeters, the height of 25,9808 divided by 2. So then you just go and compute that. Way to go, guys. I see you trying, right? That's all right now I want you to do. And you round it to that. And this is, what's the units in area? Centimeters squared, right? I know you're whispering it. I just can't read your lips. I used to be able to read your lips. Now I can't. You should have a little LED lights inside the mask, so as soon as you talk, it'll just light up. Then I know you're actually trying to say something. So if it's lighting up while I'm teaching, you're probably just calling me all kinds of stuff, right? So I can't wait for this class to be over. Anyways, keep going. This is, let's pick your brain a little bit here. 7, that was actually an old exam question. Not exactly like this, but the style of this question was actually on a provincial exam. So, you have a question, Connor? An answer for this?
Last question.
Oh.
The angle is 60.
Here you mean?
Yep.
Yes. Because it's equilateral, you could have assumed all corners are 60. You could have worked with that. Yeah. So if you used anything, if you didn't use, yeah, that's fine. If you use cosine law, you got the same thing? Okay, perfect. Absolutely. If you feel like, hey, I want to use sine law, cosine law, go for it. So on page 185, there's a blank at the first half. Leave it blank. I'm going to use that later. But give this one a try here. I'm just going to mention a few things. There are markings on there. They're not random. So if you see these markings, they're telling you that those sides are all the same, those diagonals. And then see these markings down here? Every section is the same. So like you see a bunch of right triangles. So look at all the information given all around this thing. And they want you to figure out how long the bridge would be based on the information you're given. So put your thinking caps on and see if you can figure that out. Remember, you always know sine law, cosine law, you know Pythagorean Theorem, all of those things you know, right? You know things about triangles that have two sides that are the same, yada, 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 right? So after the AC, we're going to do the quadrilaterals. Okay, we're going to start the four-sided shapes. So here we go. How long is the bridge? Well, my approach is going to be as follows, right? If this is 111.3, this is also 111.3. But I'm going to focus on this triangle right here. Because if I do that, if I figure out, if I know this is 8 feet and this is 11.3 feet, I'm going to call this section X here. If I figure out X, I can just multiply it by 1, 2, 3, 4, 5, 6, and have the length of the bridge. Does that make sense? So I'm just going to find this chunk, and hey, I can use good old friend Pythagoras, right? 11.3 squared minus 8 squared. X is square root of 6369. And when I square root it, watch what I'm going to do. 9806, right? I'm not going to round just yet. This is in feet, by the way. 1 tick is feet, 2 is inches, if that ever shows up. So length is going to be equal to 1, 2, 3, 4, 5, 6 times 7.9806. And that is 47.88 feet. So the bridge is 47.88 feet long. By the way, I take this bridge quite often and I just twist it, I change it up a little bit, add different labels. I just want you to know how to do a question like this. So this is a symmetrical shape here. Calculate the interior angles of ABC. So if you look at ABC here, A is right here. So A, B, C, they're talking about this triangle right here. Okay, and I'm going to actually highlight it orange here. So let's see what I know. I'm going to take that out. This is A, B, C. If these two angles are the same, then I could also find this. So this, I know that this is 11.3. This is 11.3. Sorry, you can't see that. And what is this here? From here to here, you can't see that, right? From here to here would be 2 times x, right? 2 times 7.9806. That is 15.96. We're going to leave it to 2 decimals, otherwise it gets too crazy there. So I'm going to find angle A. As soon as I have A, I'll be able to find B and C as well. And I'm looking at my time, and I'm going to stop there and continue tomorrow because I want you to understand this, not just write it down without thinking, right? We're going to do this tomorrow, but first we're going to do the AC on classifying. Review your sine law, cosine law a little